Hi, my name's Gabe. For this problem, we're given the function f of x equals x squared divided by the quantity 8 minus x cubed, and we're asked to find the average value of this function on the interval from -2 to 1. So let's begin by recalling how we find the average value of a function. So if we're given some arbitrary function f of x, the average value of the function f of x on the interval from a to b is equal to 1 divided by b minus a times the definite integral from a to b of the function f of x. So in this case, our function is given by x squared divided by 8 minus x cubed. A is going to be our lower limit of integration, or the lower limit of the interval, which is -2, and b is going to be the upper limit of the interval, which in this case is going to be 1. So for this problem here, the average value will be equal to 1 divided by b, we said was 1, minus -2 times the integral from -2 to 1 of our function, which is x squared divided by 8 minus x cubed, and we're integrating with respect to x. From here, we can see that the definite integral, or the antiderivative of x squared divided by 8 minus x cubed, cannot be evaluated simply. So we're going to have to use a substitution in order to evaluate this definite integral. So let's begin by letting u equal the denominator, in this case 8 minus x cubed. Du then will be equal to -3x squared dx. Since this is a definite integral, we will also need to replace our limits of integration with numbers in terms of u. So when x was equal to -2, u will be equal to 8 minus -2 cubed, which is 8 minus -8, or 16. And when x is equal to 1, u will be equal to 8 minus 1 cubed, which is 7. So from here, we can start thinking about how we will make these substitutions. In particular, we can replace our lower limit of integration with 16. We can replace our upper limit of integration with 7. We can replace the 8 minus x cubed in our denominator with u. The last bit that's remaining is this x squared times dx. We do have an x squared times dx in our du. However, we also have a -3 that we'll have to worry about. And the way that we'll get around the -3 is we can multiply our integrand by -3 and divide by -3. So in a sense, we've only multiplied by 1. So watch what this does for us. We are now at a point in the problem where we have 1 divided by 1 minus -2, which is 1 divided by 3, times 1 divided by -3, which we can think about as a -1/3. Now we have our integral. Our lower limit of integration will become 16. Our upper limit of integration will become 7. -3x squared dx we're replacing with du. And 8 minus x cubed is being replaced with u. So at this point in the problem, we are ready to evaluate our antiderivative, and then we can find our definite integral. So what do we have? Well, out front, we have 1/3 times -1/3. We can write that as -1/9. The antiderivative of du over u is the natural log of the absolute value of u, and we want to evaluate the natural log of the absolute value of u from 16 to 7. So we'll go ahead and we'll substitute in 7. That leaves us with negative 1/9 times the natural log of the absolute value of 7, which is just 7, minus the natural log of the absolute value of 16, which is just going to be the natural log of 16. So here we do have the average value of our function on the interval from -2 to 1. We can use a calculator to gain an approximate value for our average value though. So in a calculator, I will enter negative 1/9 times natural log of 7 minus natural log of 16. And that will give us an approximate value of 0.092. Thank you.